Hey guys, this is our lesson for 16.6 unit analysis, and what this is used for is to convert a unit or dimensional analysis to convert. You can use unit dimensional analysis to convert. This is something that I learned in high school physics, and sometimes it's useful and sometimes it's easier to just multiply or divide. It's especially useful if you're going to do a big conversion from one very small unit to one very large unit, and that sort of thing. So one thing they give you in the Regents exam is this top chart that looks a little bit lighter, and that's all the measurements they give you. So these are things you don't have to memorize. They do not, however, give you the units of time. I would like to think that we all know these. 60 seconds in a minute, 60 minutes in an hour, and so forth, but it would be something you may have to use. Okay? So, unit analysis is a way to convert units where you're setting up fractions that you multiply. Now that sounds scary, like, oh, fractions. But the idea is that it helps you know when you should be multiplying, when you should be dividing, and it gets your units to work correctly. This is really hard to explain unless I just show it to you. Okay? So what you want, the goal would be for your units to cancel. What cancellation means is just like when you did fractions. When you did fractions and you multiplied 2/3 times 3/8. The 3's diagonally from each other did what's called canceling. They're the same number, they cancel out and they make 1's. Okay? And then all you really have to do is multiply 2 times 1 is 2, and 1 times 8 is 8, and so forth. And then you would simplify this. This would be 0.25. Okay? Unit canceling kind of does the same thing. Okay? If I have inches over feet, and the next one is feet over miles, then the feet cancel. And you want to set up your fractions so that the units cancel. Alright? Again, this is much easier to show you than try to describe. So, the first example says, cancellation is used to find the number of seconds in a year. So we're converting seconds to a year. Well, we start out with seconds. 60 seconds are in 1 minute. Okay? And then we're going to use all of our time conversions as we go across. So 60 seconds in 1 minute, 60 minutes in 1 hour. Now, how did I know that I wanted to put the 60 on the top and the hour on the bottom? Okay, because sometimes we'll make the fraction go the other way. Here's how I knew. If minute was on the bottom in the first fraction, I needed it to be in the top on the second fraction. That is how conversion works. You want the units to cancel out. Okay, the numbers don't cancel, the units do. Alright, there are 24 hours in a day, and again, the reason that I set it up this way with 24 on top and 1 on the bottom is to make my hours cancel. And there are 365 days in a year. So days cancel. Alright, so all the units that cancel, they're gone, and the units that are left are seconds and year. And that's exactly what they asked for, the number of seconds in a year. So now what we're going to do is we're going to take all the numbers that are on top, 60, 60, 24, 365, and all the numbers that are on the bottom, which are all 1's in this case, we're going to multiply all the top numbers together and get an answer. We're going to top multiply, well, it's just 1, okay? And then the last piece of the puzzle would be to divide that out. And somewhere, oh, it didn't divide that out because we're only dividing by 1, okay? So there are 30,536,000 seconds in 1 year, okay? Here's another example of using cancellation. If we're going to convert 10 miles per hour into meters per second, okay? When I took physics in high school, everything was in metric system. We did very little in the English system of measurement, and so we were constantly converting. So 10 miles per hour, that's what we were originally given. So originally given 10 miles per hour, and that's how we made our first fraction. The 1 comes from per hour. Here's like an invisible 1 hour here, okay? 10 miles per hour means in 1 hour, you're going 10 miles. And we're converting to meters per second. Well, there are 1,609.344 meters in 1 mile. Now, how did I know that I wanted to write it that way? How come I didn't write it the other way? How come I didn't put the 1 mile on the top? Well, again, we're going to look at our units. If miles was here on the top of the first one, then miles has to go on the bottom of the second one. We're also converting units of time. So we've gotten from miles to meters, but we're also converting units of time. We're going hours to seconds. So we're also going to say 1 hour is 3,600 seconds. Well, now, they kind of skipped a little bit. They left out the fraction they went right from hours to seconds instead of hours to minutes, minutes to seconds. So this is like 60 times 60 down here at the bottom for 3,600 seconds. Again, why did the hours go on top? Why did the seconds go on the bottom? Let's look at where was hours originally. Ours was originally on the bottom. So when I set this up, I had to put hours on the top so that they are in opposite parts of fractions. So multiply all the tops, 10 times 1,609.344, and multiply all of our bottoms, which is 1 times 1 times 3,600. Then divide all that out, and you get 4.470 meters per second. Now, questions like you might see on the Regents exam, they're often, not always, but often multiple choice. So Peyton is a sprinter who can run the 40-yard dash in about 4.5 seconds. He converts his speed into miles per hour as shown below. So we've got 40 yards in 4.5 seconds, and that's the first fraction you see. And then we're going through all the conversions to get to miles per hour. So we have to feet to yards, feet to miles, seconds to minutes, minutes to hours. And it's saying which ratio is incorrectly written to convert speed. Well, I'm going to start looking at units and look for where there's a unit that's not diagonal from each other. So I have a yards on the top and I have a yards on the bottom. Okay, so that's okay. I have a feet on the top. I have another feet on the top. Well, we can't have that. So it has to do with the feet. Okay. We're going to need to flip one of those. Let's just check on the other units to see how they are. Okay, I've got a seconds on the top, seconds on the bottom. Okay, that's all right. I've got a minutes on the bottom and a minutes on the top. That's okay. All right. And then I've got all of my units on top canceled and 2 units on the bottom that didn't. Okay, so we don't have the units in the correct place. So we agreed that feet, we could not have 2 feet on top. So one of them has to change. If I switch around this one right here, okay, if I switch the 3 feet in the 1 yard and put the 1 yard on top, that won't work because then the yards will both be on top. So if I switch this one instead, if I switch the 5,280 feet and mile, that will put my feet on the bottom where it's supposed to go. And since my answer should be miles per hour, miles should go on top. in my final answer. Okay, so this is the one that has a fraction that has to flip. Choice 2. All right, let's do one completely start to finish. All right, a leaky sink loses 2 fluid ounces of water per hour. How many gallons per year will the sink waste? Okay, so somebody noticed, hey, I've got a leaky sink. They put a measuring cup, and after an hour, they looked in the measuring cup, and 2 fluid ounces per hour. Well, that's like a quarter of a cup. It doesn't feel like it's a lot of water, right? So, we won't worry about it. Except if we convert that into gallons per year, you might be surprised how much water that actually is. So we started off with the measurement they gave us, which is 2 fluid ounces of water per hour. Okay, so 2 fluid ounces of water per hour. And we're switching 2 units, all right? Fluid ounces is a unit of volume, and we're switching from fluid ounces to gallons. So I need all the measurements, the conversions that take me from fluid ounces to gallons. It also changes unit from hours to years. So I need the 2 measurements, the 2 conversions that are going to take me from hours to years. Okay, so now I'm going from 2 fluid ounces for 1 hour, and I need to go up to cups. So I have to work through there's no conversion on here that goes straight from fluid ounces straight to gallons. So I'm going to have to use all these conversions to get to gallons. So 8 fluid ounces in 1 cup, okay? So one of those has to go on the top. Either 1 goes on the top or 8 goes on the top. How do you decide? Well, I see fluid ounces is on the top here. So when I set up my next fraction, I've got to put fluid ounces on the bottom. And that's where it is. Okay, so that's how I decided the order. And I'm not going to forget to put a times sign. Okay, then I'm going to multiply, set up my next fraction. Okay, in my next fraction, I am going from cups to pints. So I already have cups on top. So I'm going to have to put cups on the bottom of the next fraction. So we've got 1 pint and 2 cups. So the 2 cups will have to go on the bottom. And we're going to keep going like this. Okay, I've got 1 pint. So the next fraction is going to have the pints on the bottom. So we've got 1 quart equaling 2 pints. So the 2 pints goes on the bottom. And finally, we're getting for 1 gallon equals 4 quarts. Quarts are on the top. So in my next conversion, I'm going to put the quarts on the bottom. Okay, so we've converted now all of our units of volume. We've gotten from fluid ounces all the way up to gallon, which is where we wanted to be. Now we're going to multiply in the fractions for units of time. Okay, so the next fraction I'm going to have is where we're going to talk about the hours and the days. All right, now I already see hours, and I'm running out of colors here. I already see hours on the bottom here. Okay, so when I go to put hours in, 24 hours, I'm going to be putting that on the top of my next fraction because I know they're not next to each other. They don't have to be next to each other, but they do have to be opposites. So if it's the hours is in the denominator originally, it has to go in the numerator when I use it for the conversion. Okay, and the last fraction, we've got 365 days in a year. I've got days on the bottom. So when I set up my conversion for a year, 365 has to go on the top. And it does. Okay, and we don't forget all of our time signs. Okay, so now we're going to go through and multiply all the numbers together just on the top. So that means 2 times 1 times 1 times 1 times 1 times 24 times 365. And that comes out 17,520. Then I'm going to multiply all the numbers on the bottom. 1 times 8 times 2 times 2 times 4 times 1 times 1. And that comes out 128. Okay? Then, last step, divide. And it turns out that if you were to let that leaky sink go, you would be wasting 136.875 gallons of water per year. Okay? That is your dimensional analysis. Thanks. Have a great day.